Okay. So for today, a couple of things that we're going to be going over. And I'm not sure, did you cover law of sines in geometry? Does that sound familiar? Whether you remember it is one thing, but law of sines, does that sound familiar? I see some yeses. So today we are looking first at finding the area of a triangle using sine of an angle. So we have a formula for area of a triangle in terms of base and height, but there is also a formula for the area of a triangle in terms of sine. And then we're also going to look at law of sines, what it is, and use it for triangles where we are given two angles and a side. So either the angle side case or the angle side angle case. You can also use law of sines if you have two sides and an angle, but that's a more complicated case that we'll look at separately tomorrow. Complicated I shouldn't say, but there's just more variation within that case. So for the first part, rather than just giving you the formula, I want you to see where it comes from. So we have this triangle here, and it says express the area of the triangle in terms of the sine of angle A. So what I want to start out with first is the formula we have for the area of a triangle. So how do you find the area of a triangle? What's the formula that you know? 1/2 base times height. All right, so if you look at this triangle, we have our base of the triangle is the side B, and that is the entire side. And then your height of your triangle is always the altitude that's perpendicular to the base. So we have our height h right here. And what I want to point out is if you draw in that altitude of h, you're creating a right triangle. So you're creating really two right triangles, but you're leaving off this piece here and creating this right triangle that includes angle A. So because we're trying to write this formula in terms of the sine of angle A, looking at this right triangle, I want to define what sine of angle A is. So in terms of opposite, adjacent, hypotenuse, how do you find sine of an angle? What ratio do we use for sine? Opposite over hypotenuse. So the opposite side to angle A would be h, again, just looking at the right triangle. The hypotenuse of that right triangle is c. So sine of A is h over c. And what we can do, notice in our area formula we have h, and h is in this formula we have for sine of A. We can solve this equation here for h, and then substitute what we get into our area formula. So if I wanted to solve for h, I would multiply each side by c. So h would equal c times sine of A. And then, like I said, I can take this expression for h and substitute it into the area formula for h. Meaning we'll get the area of the whole triangle, not just the right triangle, is equal to 1/2 times the base, which is b, times, and in place of height, we have c times sine of A. And that's our new formula. So how this is helpful, what I want you to notice here is where sine of A is located. Notice that side lengths B and C for the triangle, those two sides create angle A. So A would be the included angle of those two sides. So as long as you know an angle and the two sides that include that angle, you can use this formula or a variation of it to find the area, and it prevents you from having to first find the height and then use 1/2 base times height. So it's saving you a couple of steps. Now there are variations of this. Say you don't have angle A, but you have angle B or angle C. So another variation, if we had angle B, The two sides that include angle B are side A and side C. So it would be 1/2 times A times C times sine of angle B. And then if we had angle C instead, the area would be 1/2 times. The two sides that include angle C are side A and side B. So it would be side A times side B times sine of C. And not all of the triangles that you are working with are going to be in terms of A, B, and C. So I'm just trying to get you to realize that you're taking sine of the angle and then multiplying by the two sides that include the angle and then multiplying that by 1/2 to get the area. This is the formula you can use to find the area of a triangle. So you would, well, we'll look at example 1. So you're finding the area. The area would be your answer. This is just the formula you would use. So looking at example 1, we have find the area of triangle ABC to the nearest tenth if the angle A is 31 degrees, side B is 18 meters, side C is 22 meters. So I realize this is in terms of A, B, and C. You could just use one of these formulas. I'm actually going to sketch out the triangle so you can see how to work through it without having to memorize a formula. And in case your triangle is not in terms of A, B, and C, you would know what to do. So I'm just going to draw any triangle and label. Remember, this is kind of going back to some properties with geometry. If it says triangle ABC, just make sure for the shape with a triangle, I guess it wouldn't really matter which order, but you should label them in the order of the letters you see. So ABC, but it's more, it's more, I guess, you have to think about doing that more if you have a figure that has more than 3 sides. So for triangle ABC, angle A is 31. And then remembering too from geometry, for side lengths, we would label the side that's across from angle A, that would be side length little a. The side across from angle B would be side length little b, and the side across from angle C would be side length little c. So we know side length B is 18, and then side length C is 22. So notice we have sides B and C and the included angle. And that's what you need to have to use your area formulas. So the area of this triangle would be 1/2 times the product of the two sides, so 18 times 22, times the sine of angle A, so times the sine of 31 degrees. And if you use your calculator to multiply this, you'll have your approximation for the area, and it does say to round to the nearest tenth. Typing this in, I'll use 0.5 for 1/2, so we have 0.5 times 18 times 22 times sine of 31 degrees equals, and it's about, rounding to the nearest tenth, so it'd be about 102.0, since on the nearest tenth, that 9 would round up. And the units on the area for this triangle would be what? And its area, so meters squared, yes. Okay, questions on finding area using the sine of an angle? I'm really stressing not having to memorize formulas. So as long as you have the two sides and the included angle, that's what you're multiplying together and then multiplying by 1/2 to find the area. So then the next part is actually defining what the law of sines is, and you can use the area formulas. So these 3 variations we have up here to derive the law of sines, and this shows the relationships between sine lengths of a triangle and the sines of the angles opposite them. So I'm going to start out, so I'm going to show you how we can go from these three area formulas to the law of sines. So I'm going to set, since all three of these formulas we wrote above are equal to the same area, because they're equal to the area of the same triangle, I can set these three expressions equal to each other. So 1/2 b times c times sine of a would equal 1/2 a times c times sine of b would equal 1/2 a times b times sine of c. So those all represent the same area, so they're all equal to each other. And one thing I noticed that I could do, since this is kind of two equations combined, I could, to get rid of these 1/2s, multiply all three of those expressions by 2, and that's going to cancel out all of the 1/2s. So then I would just have b c sine of a is equal to ac sine of b is equal to ab sine of c. And then to get to what the law of sines is, this is just showing you where it comes from, I'm going to divide all three by the product ABC. So the product of all three side lengths. So as long as I'm dividing all three of them by the same quantity, it's true. It's a true equation. And what's going to happen is, for this first part, side lengths BC will cancel out, and we would just have sine of A over A. For the middle part, A and C will cancel out, and we'll just have sine of B over B. And then for the last part, AB cancels out, and we just have sine of C over C. And this is the law of sines. So do you have to know how to derive this? No, but I just wanted you to see where it comes from. You need to know the law of sines, yes. I'm just showing you, rather than me just giving it to you, I'm showing you where it comes from.
Right.
So this we can use to help solve triangles, find missing angles, missing side lengths for certain triangle cases. So it says here you can use law of sines to solve a triangle if you know either one of the following. So if you know the measure of two angles and any side, so that would be the angle side case or the angle side angle case. You don't have to know if it's the angle side or angle side angle case. As long as you know two angles and any side, you can use law of sines. You can also use law of sines if you know the measures of two side lengths and the angle opposite one of the sides. So that would be the SSA case. This is the case we're focusing on tomorrow because there's a little bit more to it. So we're focusing on having two angles on any side for today. So if we look at example 2, it says solve triangle NPQ if the angle P is 42 degrees, the angle Q is 65 degrees, and N is 5. So I'm first just going to sketch this as a triangle, not drawn to scale here, and I'll label NPQ and the side lengths as well. So across from angle N is side length little n, across from angle P is side length little p, across from angle Q is side length little q. And I know angle P is 42 degrees. I know angle Q is 65 degrees. And side length N is 5. So if you remember from geometry, to solve a triangle, that means you find all angles and all side lengths that are currently missing, that are not given to you. So we are not given angle N, we need to find it. We are not given side lengths P or Q, we need to find those. So those three values would be your answer to this question. Anything that you're not given is what you need to find. We could find angle N right away. How would you find angle N? Yes. 180 degrees in a triangle, you already know two of those angles. So if you take 180 and subtract 42 and subtract 65, you get 73, that's angle N. So all three angles should add to 180. So N is 73 degrees. And then to find the two side lengths, we need to use law of sines for that. So what you want to look at in your triangle, law of sines in this case is going to be, I'm going to rewrite it in terms of N, P, and Q. So it would be sine of N over little n equals sine of P over little p equals sine of Q over little q. So it's always sine of an angle over the opposite side, or its corresponding side length. Those are the ratios you set up. So what you want to first look for is you need one of these ratios to be complete, meaning for one of those variables, you need to know the angle and the side across from it. For this example, we just found angle N, and we know side length N. So this is the complete ratio we have. We know we have sine of 73 degrees over little n is 5. And that means we're just going to set this equal to one of these other ratios at a time to find the missing side length. So say I want to find side length P first. I can set up this ratio. I know sine of angle P is sine of 42 degrees over, and I don't know side length little p, so I'm going to leave that as P. And now I have a proportion that I can solve for P. So solving the proportion, set the cross products equal to one another. So I would have P times sine of 73 degrees is equal to 5 times sine of 42 degrees. And then to solve for P, I can divide each side by sine of 73 degrees. And I can just type this into the calculator. Careful though how you type it in. So when I'm typing this in, I'm going to type in 5 times sine of 42 degrees. You can either hit enter here and then divide by sine of 73, or at the very least you would have to close the parentheses, so just sine of 42, and then hit divide by sine of 73. However you type it in, you're going to round side length. It doesn't say in the direction, just round to the nearest tenth. So it would be about 3.5 is side length P. Any questions on how I found that? Okay, so P is about 3.5. And then we can do a similar setup to find side length Q. Now, I still want to use, or I'm still going to recommend you use the ratio sine of n over n and pair that with the ratio sine of q over q, because this is the ratio you know for sure. Side length P was an approximation. So rather than now using this ratio, I would still use the one that we had from the start. So sine of 73 degrees over 5 is now equal to, and I'm going to pair it with the sine of q over little q. Angle q is 65, so sine of 65 degrees over q. And I can solve for q like I solved for side length p. So set the cross products equal to each other. Q times sine of 73 degrees is equal to 5 times sine of 65 degrees. And then divide each side by sine of 73 degrees. And round to the nearest tenth. So we would have 5 times sine of 65 divided by sine of 73. And Q is about 4.7 if you round to the nearest tenth. And you have found everything that was missing, so you've solved that triangle. Any questions?